Hi everyone. In this video, we are going to learn how to write a geometric series in sigma notation and how to find the sum of a geometric series when it's written in sigma notation. Let me start with a simple series. 1, -3 plus 9 plus -27 plus 81 and so on. First of all, you have to figure out what kind of series is this. If you take any number in this series and divide it by the previous term, you will get the same number. For example, if you take -3 and you divide it by the previous term, which is 1, you will get -3. If you take another term, let's say -27, and divide it by the previous term, which is 9 in this case, you will also get -3. So when the common ratio is constant, that means this is a geometric series. And the common ratio for this series is -3. I already talked about the symbols R, U1 in my previous videos. So if you don't know what I'm talking about, please watch those videos first and then you can come back to this one. So for this series, the first term, that is U1, is 1. The common ratio is R, which is -3. Now, what is the pattern of the series? Like, what pattern is it following? You can see that the first term is just U1, and to get to the next term, you have to multiply by -3, which is the common ratio. To find the second term, you need to multiply the common ratio with the first term. So you will have U1R. Plus, if you want to find the term after this, you also need to multiply -3 to it. That means you're multiplying the common ratio again with the second term. If you multiply R with U1 and R, you will get U1R squared. The term after that, also you need to do the same thing, multiply the common ratio with this term. So I'm going to have U1R squared times R will give me U1R3 and so on. Now we have to represent this in a sigma notation. I will start with this. And the pattern of this series, it's the U1 stays constant, but the R keeps on increasing. The power of R is 1 here. The power of R is 2. So it keeps on increasing by 1. That means it must be R to the power of 0. The U1 stays constant, but the R keeps on changing. That depends on the term of the series. For the first term, the R is 0. So I'm going to write, the power of R is 0. So I'm going to write k equals to 0, where k is your power. This is where you write the lower limit of the series. I also discussed this before. And this is where you write the general term of this series. The general term of this series is U1R to the power of k, and this k starts with 0. So the lower limit is k to the power of 0, and it will keep on going until we don't know how many terms are there in the series. So I'm just going to write n. So I'm just assuming that it will stop at U1R to the power of n, which is the last term. For this series, we know the first term and the common ratio already, so you cannot leave it like this. You have to substitute the numbers. I'm going to write n, k equals to 0. Instead of U1, I will write 1, and instead of R, I will write -3 to the power of k. So this is this geometric series in sigma notation. Now let's look at another example where you will have the number written in sigma notation already, and you have to find the sum for this. Let's say the upper limit is 8, lower limit is -1, general term of the series is 256 half k. This symbol, it means sum. That means you have to find the sum of the series from k equals to -1 to k equals to 8. This is where you stop. If you look at this series, it's also a geometric series because this stays constant and the ratio keeps on increasing depending on the number of terms. If you want to find the first term, all you need to do is substitute the lower limit into the general term of the series. In this case, it's going to be 256, then in bracket half to the power of -1. This will give you 512. If you want to find the second term of this series, you need to substitute k equals to the next number after -1 because you started with -1. It's going to be to the power of 0. This will give me 256. For the third term, I'm going to do the same thing, but my k will be the next integer, which is 1. So 256 times half will give you 128. You can see that this is a geometric series. Take any term, let's say the middle number 256, divided by the previous term, you will get half as well. The common ratio for this series is half. The first term of this series is 512, and this means you have to find the sum of the series. Since this is a geometric series, we know already how to find the sum of a geometric series. S of n equals to u of 1 r to the power of n minus 1 over r minus 1. I know the first term of this series, I know the common ratio of this series, but I don't know the number of this series yet. That means if you want to use the formula for the sum of a geometric series, you need to figure out the number of terms for this series. Now this case started with -1, then 0. From 1 to 8, you have 8 numbers. 8 numbers plus 9 plus this, which will give us n equals to 10. If you count -1 and 0, these are 2 terms already, and from 1 to 8 you have 8 more terms. So 8 plus 2 will give you 10. That means the number of terms in this series is 10. Now that I know the n, I can easily substitute this into this formula, and it's going to give me S of 10 equals to, u1 is 512. In bracket, I will have half to the power of 10 minus 1 over half minus 1. If you put these numbers in the calculator, you will get something around 1024. But as I told you in my previous videos, when the ratio of a geometric series is less than 1, that means this is a convergent geometric series. When the series is convergent, you don't need to use the formula for this sum. You can use this straight away, which is sum to infinity, and this equals to u1 over 1 minus r. The first term in this case is 512, and if divided, you will get 1 minus the common ratio, which is 0.5. This will also give you 1024. So when this ratio is less than 1, you don't have to do all this calculation. You can just use the sum to infinity and find the sum straight away. The reason I showed you this formula is when you have a divergent geometric series, that means when the ratio is more than 1, you will need to use this. And to use this, you need to know the number of terms as well, and this is how you can find the number of terms. Okay, that's all for today.